Okay, so let's look at this um, situation. We've got this as the open-ended task. We've got that m equals x to the power of 4, n equals x to the power of 6, and we want m to the power of k. It's a lot happening here, a lot of algebra. N to the power of h equals x to the power of 30. So what we've got here is x to the power of 4 all to the power of k times n x to the power of 6 all to the power of h equals x to the power of 30. Now, if we just look at the indices, which is what we're going to get into soon with logarithms, that's what logs are. They're powers in lots of ways. We're just going to consider the powers. We know that 4k plus 6h equals 30. And we know that both k and h are greater than 0 and whole numbers. So what we could say is, let's say k equals 1. So this is 4, k equals 1. So this is 4 plus 6h equals 30. So what does, if we take the 4 over to the other side, it becomes 26. 6 times something equals 26. That can't be a solution. What about when k equals 2? When k equals 2, this is 8 plus 6h equals 30. Is that a solution? We take this over, we're going to get 22. 6h equals 22. Is there going to be any solutions? K equals 3. We might be a bit luckier here, I think. K equals 3. So when k equals 3, we get 4 times 3 is 12 plus 6h equals 30. Therefore, this must be 18. So h equals 3. When k equals 3, h equals 3. Is there any other solutions? I don't think so, because when k is 4, you get 16 plus 6h equals 30. That's going to be 14. When k equals 5, what are we going to get? There might be one other solution, actually. When k equals 5, we're going to get 20 plus 6h equals 30. So 6h equals 10 doesn't work. What about when k equals 6? So what we get is 24 plus 6h equals 30. I hope you can see that one of these answers is going to be k equals 6, h equals 1. So k equals 6, h equals 1. Really nice question. We did lots and lots of algebra. It was quite hard to get started with lots and lots happening. Let's look at this consolidation task. I think this was the consolidation. It may have been the extension task, actually, the extending prompt. We know that we're dividing now, and we want x equals y. How many different values of y can we get? What we do know is that k and h differ by 1. They're both still positive. So let's say that if this is k, h is k plus 1. So there's the two situations. This could be 1 more than that, or this could be 1 less. So let's start with h equals 1 more. So what have we got? We've got x to the power of 4k divided by x to the power of 6k plus 1, or 6 lots of k plus 1. What would y equal in that case? Well, it all depends what k is, doesn't it? And there's a whole heap of answers here. This is going to be x to the power of, remember we minus the powers, so 4k minus 6k minus 6, because we're minusing the whole power, equals x to the power of y. So what does y equal? 4k minus 6k minus 6 equals y. So what's that? Minus 2k minus 6. So there's a whole heap of answers. They're all going to be negative, though. K was positive, So when k is 1, what do you get? Minus 2 minus 6. So when k equals 1, you get y equals minus 8. When k equals 2, what do we get? We get minus 4 minus another 6, so minus 10. When k is 3, we get minus 12. You can check that if you want. So in this case, we're getting negative answers. We're getting minus 8, minus 10, minus 12, minus 14. Let's look at the other situation. If the k and h differ by 1, but let's look at k and k minus 1. Let's see if we get some different answers. And I'll do this one slightly slower. I rushed the other one a little bit, maybe. What do we know? M to the power of k divided by n to the power of h. But to the power of h in this case is k minus 1. So instead of writing h, I've written k minus 1. Now, what does m equal? X to the power of 4. So it's x to the power of 4 outside of k divided by, what does n equal? X to the power of 6, x to the power of 6 outside of k minus 1. Now, maybe you can see what might happen here is this negative, when we minus the indices, that's going to make that a positive. And we know this equals x to the power of y. Let's look at the indices. 4 times k minus 6 times k is 6k. 6 times 1 is plus 6 equals y. So what values of what can y be? Again, if k equals 1, remember k must be greater than or equal to 1. That was one of the stipulations or one of the rules we started with. If k equals 1, what do we get? We get 4 minus 6 plus 6. So y equals 4. And maybe some of you have realised I could have collected like terms here, couldn't I? Made it something easy like this. This was our other value. This was the first value that we were using, equals y. What about when k equals 2? What do we get? 8 minus 12 is minus 4 plus 6, y equals 2. What else have we got? We've got when k equals 3, we're going to have minus 2k. Remember, this is really minus 2k plus 6. Y is going to be 0. And hopefully, again, you can see this pattern emerging. 4, 2, 0, minus 2, minus 4, minus 6, minus 8. Do we need to keep going? No, because it's this pattern here. So really, what are the values for y? It's this sort of subset. Starts at 2, 2, 0, 4, 2, 0, minus 2, minus 4, minus 6, minus 8, etc., etc. They're all the values that y can be. Hopefully that sort of made sense. It's just working with powers and those index laws. Really, really important. Thanks.